Mr. Harris here, and welcome to a new video. In this video, we'll continue to wrap up the topic of displacement reactions by doing a couple of questions. So here, question one, what will happen if you keep a copper 2 sulfate solution? Now, my habit, if when I see a compound, I prefer to write down its chemical formula on the top. Copper 2 sulfate, I know the chemical formula for this is CuSO4, and in an iron vessel. Iron, I know, is Fe. Explain the observation. So the best way to do this is let's use a, a chemical equation to see what actually is going on. Copper 2 sulfate, let me write this Aq plus iron is a solid. Now, obviously, we know this is going to react. It's a displacement reaction. Now, why is it displacement reaction? Because if we still remember the metal reactivity series, iron is much higher in the metal reactivity series when compared, not much higher, but it's higher than copper in the metal reactivity series. Or, as we know, I could just say it's more reactive than copper. So it will undergo a displacement reaction. And as a displacement reaction, we know it would sort of overtake the sulfate ion, okay, and the copper is left behind. So plus copper. So this is the chemical equation. Now let's answer the question. It says, what will happen if you keep there? So in an iron vessel, eventually, we could say the answer, you could say eventually there will be holes formed in the iron vessel. Okay, and then a lot of people stop your answer here. Now, you're not answering the question. You've only answered the first part of the question. You haven't answered them asking you explain the observation. Now, what is our observation? As I just wrote, you can see what happens here, right? So you need to mention why does this occur. So what you see in the chemical equation is what you're going to write. So iron is more reactive than copper. And then you can write it will react with copper 2 sulfate to form iron 2 sulfate solution and copper. Thus, at the end, you can see the main point should be that copper deposits on it. So iron is more reactive than copper, and a displacement reaction occurs. And finally, you mention, I'll use this color, thus copper deposits on the vessel. Okay, so that's for question one. Now I'll move on to question two. So the following experiments were carried out to find the order of reactivity for the metals cobalt, magnesium, silver, and tin. And here are the observations. The experiment observation, let's look at question A. Deduce as far as possible, as much as you can, in meaning the order of the reactivity of these elements, of these metals. So here, let's look at experiment 1. So I'll label this as 1, this is 2, this is 3. Experiment 1 here, adding tin to silver nitrate solution, and the observation is a silver layer formed on the tin. This means that tin, you can see it's a metal. Silver, as it's mentioned, it's also metal. It means that the tin is more reactive than silver. That's why it can displace it, right? That's why it forms that silver layer on the tin. So, in other words here, tin is more reactive than silver. Okay, now let's look at the second one. Adding magnesium to tin. So magnesium to the solution of tin to nitrate, and this one also a gray deposit is formed. That means when I place magnesium to tin, in other words, magnesium is more reactive than tin. So Mg is more reactive than tin. The last one, adding tin to cobalt to nitrate solution, there is no observable change. Now, what does it mean there's no observable change? That means tin is not able to displace cobalt. When does that happen? That happens when the solution, the metal in the solution that is cobalt here, that is more reactive. So if this is more reactive, obviously it won't be able to displace it. Tin won't be able to displace it. In other words, cobalt over here is more reactive than tin. Okay, now we have found out. Now it says deduce as far as possible the order of the reactivity of the metals. Okay, so let's answer that question here. Which one is the weakest? Can we figure out the weakest? The weakest obviously is silver. So I'm gonna start there. And then afterwards, between cobalt, tin, and magnesium, tin would be the second last. And then how about between magnesium and copper? How about between magnesium and copper? Not copper, sorry, cobalt, magnesium and cobalt. Is there a way for that? Is there a way to figure this out? At this moment, among these three experiments, we don't really know. So at this moment, maybe I'll write magnesium or copper, not copper, I'm saying copper all the time. Cobalt is greater than tin or silver. Because at this moment, I don't know. And from here, you can get the hint. It's saying as far as possible, right? As much as possible. So this is a hint. And that's exactly where they're asking question B. What additional experiment do you need to do in order to know the order for the four metals? So that's very simple. What you're going to do is, so you need to do an experiment for magnesium and cobalt. How can you do that? Basically, just follow the pattern that you see here. Just write a number 4 and follow that pattern. So let's say you add magnesium to a solution of cobalt to cobalt. Now, you're like, sir, what do I write? Don't worry, just look here. You can see there's an example there, cobalt 2 nitrate. Just follow that example, cobalt 2 nitrate solution. Now, don't stop there. Now you need to explain what would happen. What would happen if magnesium does displace the cobalt? If you see that there is some silver or some metal that is formed, that means magnesium is more reactive than that. Okay, okay. But here, if this was a 1 mark question only, you don't need to explain it. Here, they're not asking you to explain it, but I just wanted to tell you that if it's a 2 mark question, they're asking you to explain, then you're going to explain it in this way. But here, this is where the question ends. Okay? And then now let's go to part C. Write chemical equations for the following reactions. Reaction between tin and silver nitrate solution. Okay, now let me get a bit more space. Okay, reaction between tin and silver nitrate solution. Now the chemical formula for tin is SN. Now silver nitrate, what is the chemical formula? I've taught this a couple of times now. First off, what you're going to do is you need to know what are the ions. So silver is Ag plus, nitrate on the other hand, I'm going to use a different color, green. Nitrate is NO3 minus. So you're going to do the cross method way. You look at the number and you bring it down to the other side if there is any number. Here for Ag, on the other side where the nitrate was, is there any number there? No, it's just 1, so you just put the 1 there. For NO3 here, for Ag plus, it's just, actually we know it's 1 plus or 1 minus, right? We add the 1 here, but as I taught you, we don't write the 1, so it's just AgNO3. So plus AgNO3. Okay? Now, we're going to write down, tin, because I'll also write the physical states for your tin, because it's a metal, it's a solid. And here, silver nitrate, it's a solution, so AQ. Now, what will it form? Now, to tell you, tin ion is actually SN2 plus. It has a 2 plus charge. Okay, so it will form SN and the nitrate. So here, tin is 2 plus, nitrate is negative charge. So remember, do the cross method. You bring the number to the other side, bring the number to the other side. What do you have? SN, okay, and NO3. Remember, there you need to add a bracket, because if I don't add the bracket, if I just write the if I just write the 2 there, it becomes NO32, and that's not what we want. You add a bracket. So you see it's SnNO3 with a bracket 2. So here I'm going to write that back down. You have SnNO3 2, and of course you have your silver that's left behind. Okay, actually, to tell you, later on in book 2A, you'll learn more about why is this an AQ, why is some of them solids, but we'll leave that for later. Now you need to balance it. Okay, on the left hand side, you can see you have a tin here, there's one tin here. On the left hand side also you have one Ag here, one Ag. So by NO3, you can see that NO3 on the right hand side, you have 2 of them, but here you just have 1. So you need to balance this on the left hand side by adding 2 to the front. But now there's a problem. Now that you have added 2, remember this 2 stands for, it's for the whole thing. Just imagine there's an imaginary bracket there. So it would mean that it's 2 times silver, 2 times Ag, and 2 times NO3. That means now you need to balance back the silver atom or silver solid metal on the right hand side. So we added 2 here. So now it's perfectly balanced. Everything is balanced now. Okay, so that is for C1. Now let's do it for C2. I'll bring it back. Magnesium and tin 2 nitrate. Okay. Magnesium is Mg solid plus tin 2 nitrate. Tin 2. Okay, here. Actually, they're giving a tin 2. Here, this is what I meant. SN2 plus. That is SN2 plus. You can get the idea from its chemical name. So tin 2 nitrate solution, as we've just found, it is SnNO32. So I'm just going to copy it here, SnNO32. Okay, now what does it form? It would obviously form magnesium nitrate. Now magnesium nitrate, what's the chemical formula? It's Mg2 plus. We know magnesium ion is Mg2 plus because magnesium is in group 2. Nitrate ion, we know it has a 1 negative charge. Again, do the cross method. So the number goes here, number goes there. Then you know it will be MgNO3 with a bracket 2. So here you would form MgNO3 2. Let me add back the AQ. Okay. And of course we have our tin metal left behind. Don't forget that. Then you will check if all the atoms are balanced here. There's 1 magnesium, it's balanced, 1 magnesium, balanced. How about the tin? On the left-hand side, there's 1 tin. Right-hand side, there's 1, balanced. Then finally, look at your nitrate ion. There's 2 of them on the left-hand side, and there's 2 on the right-hand side. So that's also balanced. Okay, so this is how you do displacement reactions. So a reminder for displacement reactions, you will need to focus on the metal reactivity series, which metals are more reactive, and that will displace the solution of the less reactive metal. And for chemical equations, remember you need to balance the left-hand side with the right-hand side. Look at all the number of atoms. And remember to correctly write down the chemical formulas. Using the cross method would be the best way. But there's another method. There's another method for you to do it. There's another video that I made it. You can just check it out from the playlist. So that's it for today. I'll see you in the next one. Bye.